All right, so we agreed to get started, 2:05. Just going to do a little intro first. Welcome everyone for joining us. This is our, third office hour for the LMCache project. And we're excited to have Martin Hickey here to talk to us. I'll let him get started in a minute, but just wanted to let you know, in case this is your first time joining us for office hour, we will do these monthly. We do them on the second Thursday of the month, and we have a dedicated channel for this. If you haven't joined it already, you can join it at office hour in the LMCache Slack. And we do have a topic for next month. We've got folks from Tencent joining, recording a session for us, and then we'll do live Q&A about P2P caching. And then we're looking for a topic for April. So if you have something you'd like to talk to the LMCache community about, please reach out to me and let me know, and I can get you on the office hour schedule to present. So without further ado, I'm going to stop sharing this sort of intro slide here and let Martin take it away. But first, is there anyone from the project that wanted to say anything before we get started? Anyone else has anything to announce? All right, I guess that's a no. So I think that means, Marty, you can get going. Are you able to? Do you have slides? Do you want to try sharing your screen?
Yeah, give me 2 seconds there. I'm going to just share there. Thank you all for the intro. Okay, will we try and get professional and kick it off?
Yep, go for it. Do you want me to wait? Do you want me to do something else, or you can get going?
I'll just get going with it. Okay, folks. So thank you to Mo and to Nick, and thank you for the community for asking me to come on today and talk about this topic. So in the era we're in at the moment with large-scale AI inferencing, ensuring that efficiency across distributed environments is becoming essential. As our workloads are growing, so does the need for more intelligent scheduling and memory reuse strategies. And we're probably seeing this more and more because, initially we might have started out with, our requests to models, but now the workloads is that request to a model now may require multiple requests in the background with agents, etc. So what is event-driven KVcache aware routing, you're probably asking? Also, more importantly, how does it apply to you and I? And because we're here in the LMCache community and the office hours LMCache, what has this got to do with LMCache? So hopefully over the next maybe 20 minutes, half an hour, I'll be able to answer these questions as I go through the slides and the demo, explaining around events and the routing. My name is Martin Hickey, and I work over at IBM. And I've been working in open source communities for the last probably about 10 plus years or more, primarily around cloud native spaces, and for the last number of years in around AI communities, because of obviously the growth of AI and the ability to being able to inference and distribute workloads in AI. So before I kick into some of the details, I first want to do a little level set. So just in case anybody is new to the LMCache community, or they may haven't heard of distributed LLM inferencing before, I just want to touch on the two of them. So I've used, I suppose, the lovely little phrase we have in the LMCache community for what LMCache is. And if you haven't heard of caching before, it's in the AI space. Caching layer is really, it's for the attention states, for the key values you get with your tokens. So when your tokens, when your tokens are converted, the ability to be able to cache those tokens between the different attention states, so that you don't have to be computing the tokens over and over again. And KVcaching is an inferencing time optimization technique for large language models, and it stores these intermediate attention states, which are the key values, as opposed to key value pairs that we might know from programming, to prevent redundant computations between the different states. Now, what is distributed LLM inferencing? So this is inferencing that supports a system that splits requests across a fleet of hardware. So this may include physical, cloud servers, etc. And the idea here is that you want to be able to break up that request into assigned portions that you can run in parallel, and it can create an output. So what you're trying to do here is you're trying to break down the model and parallelize its workloads to reduce latency, which is always what we're looking for, increase your throughput, and allow models to run on more resource-constrained hardware. So that's another key aspect of our models when we're trying to run them is how can we run the models better without larger hardware, etc. And the result of all this, with your caching and your distributed LLM inferencing, is that you provide a more resilient and observable system, and you deliver consistent and scalable AI-powered services. However, we have an issue today with LLM inferencing and routing, and this is something I'm going to cover in the next few slides. And the problem we have with distributed LLM serving for the last while, or inferencing, has been inefficiency. And the first part of this has been around the routing and the repeated computation of similar prompts. And what's happening here is that the routing hasn't been able to make use of caching of key value pair or key values from previous runs. And this is also leading to underutilization of the caching. So we have the caching, except the routing isn't able to find this caching. So we're ending up with, as I say, repeated computation and then the underutilization of the caching that's already there. And this leads to two big bottlenecks for users, which is, longer for requests to come back, which is higher latency, and also the costing, because it's going to cost more, because each time you're doing computations that are not necessarily needed because we have it already cached. And with the new workloads that we're getting, especially with agents, etc., it's exacerbating this now because they're a key part of requests to models. So the solution to this is KVcache aware routing. And what is this? So this is routing that's scheduling and load balancing of techniques for LLM inferencing that routes every incoming request to the worker, which is your pod, your node, or GPU, which is most likely to already contain the relevant key value attention cache. So in other words, finding the routing is now able to find where the particular cache is stored and able to use it and not have to be recomputed. And this dramatically will reduce the latency and the compute costs, because, as I said, it removes that unnecessary recomputation each time in the attention states. And I'm going to look at some of the distributed frameworks in a few minutes, like LLMD, NVIDIA Dynamo, and KServe, and how some of these communities are starting to look at that. So, as I mentioned a minute ago, routing previously was more concentrated on the distributed of its loads where its LLMs were served, and not necessarily accounting for the caching. So how now can the routing become aware of where the caching is? And this is going to be through events. So the idea of the KV events, which shows the different changes in the caching state that's been used by the distributed LLM platforms. We call this event-driven routing. And what it is here is these events enable the routers to make a more intelligent decision based on the current caching contents. So you're probably wondering, what has this got to do with LMCache? Well, if we look at the stack here of where on top you have the distributed platforms. So this is where it controls the different workloads, where it does the routing, etc. And it will call its different, the inferencing engines that it supports and it's deployed. And these engines then can use caching layers like LMCache. The key part here is that the caching layer needs to inform the platforms where the caching is, if any caching gets removed, or if the caching has been moved. So in this way, then the distributed platforms always have a complete picture or a real-time picture of where its caching is, and it can route into the most relevant workers, pods, etc. So a key part of this has been for LMCache is to, first of all, to generate the events when it's done a caching operation. Those events are then sent to the inferencing engines. In this case, LMCache at the moment supports VLLM and SGLang. And it's the inferencing engines then that publish the events. Now, they may also publish their own events in addition, and this gives more and more visibility to the distributed platforms.
Martin, there's a question in the chat. Is KVcache-based routing becoming the de facto method for large-scale disagg inference?
Sorry, repeat that again. I didn't catch one part of it near the end.
Is KVcache-based routing becoming the de facto method for large-scale disagg inference?
It is a key part of it. You know, it's I suppose you'd call it's a major cog in the overall part of routing. So it brings more visibility to the routing. But to know where your caching is, where your tokens are stored, that's where you'll want to send the traffic as well. So it's down to the algorithms that are used, I think, is the key part. But by providing this, it's a key part of the overall routing. Now, I'm not an expert. I will say I'm not an expert in KVcache aware routing. I'm looking at this more from the angles of LMCache and the events. So these requests have come in from the LLMD community, from NVIDIA Dynamo, and possibly other platforms as well. We look for these events. I hope that provides some context, does it, Mo?
Just waiting to see if the question asker responds in the chat or jumps in. But...
Hi, Mark. Yes, thank you.
Yeah, thanks.
That's okay, is it? Yeah. Okay. All right. Okay. So from that perspective, it's these events is going to bring that visibility to the distributed platforms. At the moment, the VLLM and SGLang is using the 0MQ message library. So it's brokerless, and it has the same concept of all messaging queues. You have a topic, and it publishes to that topic. So any platforms that want to use those events, then what they have to do is to subscribe to the particular events. Okay, so what does this mean from an LMCache point of view? So what we've done in LMCache is we are generating these events from version 0.3.13. So you need to pick up that version. And we've also put hooks into VLLM and SGLang to be able to gather the events and then publishing them through their broker then, or sorry, through their message library then. And therein, that hook went into version 0.13 of VLLM, and hopefully it'll make it into 0.5.8 of SGLang. At the moment, the PR is nearly ready to go. We're just waiting for the final review and merge of that. Now, by default, the events are not enabled. So if you want to enable it, you need to use the enable_kv_events flag for LMCache. And also, if you want the inference engines to publish the events, you need to use their flag kv --kv.events.config. And you can see on the right hand side the config example. It shows you how to use it for VLLM. SGLang is slightly different. It doesn't use the property enable_kv_cache events. You don't need to put that when you're using SGLang. But I put a link to the documentation above, or documentation, and that explains how to get the events published through VLLM and SGLang, etc., and those details. So what do the events look like? So in the first phase of this, we have done just the block stored, which is the name of the data type for cache storing events, and you can see the different types of fields. Now that hash is a bit wrong. The first hash should say block_hashes, or sorry, should say block_hashes. Yes, and then your parent hash token IDs, block size, lower ID, medium, and lower. So what do these fields mean? Well, the key field here really is block hashes. So this is a hash of the different token IDs. And how this is important is this is the key for the routing, or the KV aware cache routing. Now, I'm going to talk in relation to LLMD because I talked to one of the engineers that works on LLMD, and what Maroon said to me was the key for them is that they can map the hash to the particular worker where this came from. So they know the particular instance of the inferencing server. They know where the event has been generated, so they can keep an indexer which will give them a mapping from the hash to the particular where this is stored. So that's the first aspect of it, and it gives them their hit as well. Now, the other fields then is in relation to the parent block hash, is that if it's broken down into multiple chunks, then it's like a linked list. So the first one will have we'll have an empty parent block hash, and then the next one then will point to basically this block hash here, which is 4333, and so on and so on. The token IDs are the different token IDs that have been stored. The block size then is the size of the particular chunks, and our mediums will be CPU and possibly GPUs, and in time storage, but we haven't come to that yet, and I'll touch on that near the end of the presentations. And the final one is LoRa. We're not using that in LMCache at the moment, but we may use it in time. And LoRa ID now has changed to LoRa name, but I haven't updated that in the slide, so sorry about that. Okay, before I go into a demo and see how we're generating the events being published by VLLM, any other questions, Mo or Nick?
No questions in the chat so far. Any questions from the group? You can feel free to unmute if you have a question.
Okay, let's just go into demo. So I'm just going to do a short demo at the moment to show how this way is working. So can you see terminals?
Yes, we can.
Okay. Are they big enough, do you think, or do I need to bring the text up a bit?
It really depends on the size of your display. For mine, it's good, but
okay,
a small display, it's going to be hard.
I'll just go up slightly. Okay. Yeah, across the window would come across. 1 second. Let's do that. Okay. So on the left side terminal, on the far left terminal, I have VLLM running with LMCache as its caching layer. On the top right hand terminal, I have a small little client, which is, let's go up there, a small client that Python client that is listening to the particular channel that VLLM is going to, or the topic that VLLM is going to post the events to. So it should just spit it out onto the screen. And down below on the bottom right hand side, I have a simple prompt, and I'm going to prompt the model that's loaded. It's a Qwen 314p model. Now, all this information is inside in the docs. As always with the open source communities, if you find any holes, please raise an issue, push a PR. We're always welcoming that, okay? We always like help out in this. And as I say, this is a new feature that we just started at the end of last year. So any feedback would be great. Also to anyone from the different inferencing platforms or distributed platforms, please reach out to us as well if you need something done and more as well. I'd also like a big shout out to some of the folks from NVIDIA that put in the publisher into VLLM and also into SGLang. So that means we can come along and use it, and also the inferencing engines can use it as well. So well done to all. And all to the other people, also to other people within the community that have been pushing this, these events and asking us in the LMCache community, can we do them? So thanks for reaching out. So what I'm going to do is I'm just going to prompt the model, and we should see on the left hand side, it should cache some of the tokens, and then subsequently then when it's finished the actual request, then you should see the events get put out or displayed out in the top right hand side. So let's see if the demo gods are with me. Okay, so we can see here that down here in the bottom left, we can see here that LMCache spits out that it stored its tokens, 32 out of 32 tokens. And we can see here in the top right hand side. Now this is a very simple client. It just spits out the actual data type fairly roughly, but you can see here that the details come out here. You can see here the different chunks, and you can see here that one. You can see here the parent block the parent block is going to point to the previous one, and so on down along. And you have the different tokens as well, and the CPU. So this is really what we're doing here is getting those events when we do operations in LMCache, getting them up into the inferencing engine, and then they can be propagated back up to the distributed LLM inferencing platforms. Okay, any questions?
Actually, I have a question.
Yep.
Is it all right to ask? Why is there a parent? I mean, maybe I don't understand how LMCache works in the backend, but why are there like 4 blocks, and why does each one have a parent when you only send one request in?
Yeah, so what I've done here is I've put the chunk to be quite low. So I've made the chunk, I think it's about 8, down at 8 bytes instead of something higher. So that's why it's broke up basically.
Okay.
Yeah. So I've done that because we changed something. Yeah, sorry, someone want to say something? No. We changed something a while back that we made the chunker higher by default. I think it's 256. So I just load it down so that we can see it coming out and you can display on the screen. So it's more for this simple example than anything else. But generally, the chunk count would be higher rather than lower here. But just for this simple example, I just wanted to display it.
Got it. All right. Thank you.
You're welcome.
And we have another chat question in the chat. So here medium means KV blocks are sitting in CPU DRAM.
Yes. So here in the situation, we're offloading CPU. So that's why it's CPU. But if it goes to disk, then we'll have disk. But that's follow-on work we need to do on it to give better granularity. And I'll touch on that near the end, or probably in the next slide, I think it is.
Awesome. And we have another question from Ugur. Do you want to unmute?
Yes, hi Marty. So VLLM and LMCache can have different block granularity. Like VLLM, for instance, I believe by default using 16 tokens per block, whereas in LMCache we can have much larger size. How does it work here?
In what way?
If I have, for instance, if I have a chunk size, let's say 256 in LMCache configuration, is this report, is this publish an event for all those 256 chunk include like 256 tokens KV? Because VLLM can have different granularity, if I remember correctly.
Yeah, this is more on the chunking than the granularity.
Okay, thank you.
Yeah.
Oh, and there was one more follow-up from that other question from the chat about CPU DRAM. Is it there for NVMe 2? I'm not familiar with that acronym, so sorry about that. If I said that wrong.
Is it for, sorry, I didn't catch that.
Is it there for NVMe 2? Oh, they mean storage.
Oh yeah, down the line, hopefully we'll have storage as well. So at the moment it's just the CPU offloading and GPU to GPU, but hopefully then we're going to, as a follow-on, we're going to make the medium more granular, more fine-grained.
Thanks for that clarification, Himanshu.
Okay, will I continue on, or what do folks think?
No more questions from the chat.
Okay, so I'll just go back to the deck for now, and we can follow up with more questions as we go along. Okay, can you see the deck?
Yep, we see a rocket.
Excellent. Yeah, I just said I'd stick that in there because I was at NASA there last year. So, right, I'm going backwards, I think. Okay, so what are the next steps for KV events? Specifically from a LMCache point of view, both 1 and 2. So for 1, as I think one of the listeners asked a few minutes ago, was we need to make the medium more granular in visibility. So we need to get more into, you know, storage and disk, etc., like that, because it's CPU, GPU at the moment. The second one in it is around, at the moment we're just generating events for storage. We must look at, are we going to do events for removal and also for moving if cache gets moved, etc. So these are things I think we need to discuss if they're viable or not in the community. And the final one really is, it's across the open source community here. So good work has been done by folks around starting a standard for the event types. So the data structure for the event types. The only problem with that is at the moment VLLM has one definition and SGLang has a similar definition, only 1 or 2 fields aren't the same. So I think we need to look at where do we put that standard, because at the moment LMCache, we're using the definition from VLLM, but I wonder going forward, do we need to find a common ground or common place so that we have better interoperability and consistency with the event handling? So I think that might be next on the agenda. So I suppose overall, it's improve our cache awareness so that we help the routing, and then basically the cross-platform capability across the different inferencing engines. Right, to finish up, the key here always is going to be for, you know, the users, getting that latency down and the cost. And the parts of that really is, the key part of that is making the routing more aware, more intelligent, more optimal, and that requires getting information about where the caching is, getting those events, and that's our work in, and that's the work that in caching layers like LMCache needs to do, and in the inferencing engines like VLLM and SGLang, etc., need to do to be able to get those events up there. And we're working on that in the community, and I think it's going to be an ongoing thing over the next year, and we're going to see more and more progress as we go along. I think there's probably a lot of progress done at the moment in the inferencing layers, but I think, you know, it's what we do here and the information we give it is going to drive it forward. And the key here is just the workloads and the amount of traffic and so forth, helping with that. So that's it for me.
Ugur, yeah, do you have
Yeah.
a question, comment?
Yeah, hi Marty. And I have another question. So you mentioned that you are planning to extend this to storage, especially from a shared remote storage perspective, and I'm talking about like a parallel file system or object storage. Do you see a value of extending this? Because in such cases, like theoretically, right, the access latency is going to be uniform across all the GPUs. I just wondering your, view on that.
If I'll be honest with you, I've put it out there more than I've had time to look at this or discuss it with, we'd say, the other people in the LMCache community, like Iha and Samuel and Jai. So I think this is a conversation we need to have. So, but I want to put it on the agenda to know what we can do and how far we can push it, if that makes sense. So I haven't looked at it technically yet, is the answer to that. So yeah, sorry about that. I don't have a full answer on it or visibility yet.
Oh, that's fair enough. I'm just curious, like, maybe there are like other use cases than just routing to, consume those. Like, I don't know right now what is another use case for these like events, because you keep track of every cache, operation basically.
Yeah, no, I don't know how granular we can get or how fine-grained we can get. And maybe that's something that'll be driven by the routing and the routing algorithms from the inferencing platforms. And also, there's far more experts out there than I am on this that can probably give better answers in it. But I think it's a conversation we'll probably have definitely in the LMCache community in the next couple of weeks. But I think it's a very good question.
Thanks again.
Mo, Mo and Nick, if you get a chance with some of these questions, you might persist them, and we can look at them afterwards as well.
Yeah, we have another question in the chat. What event do you think will benefit most the latency and performance when KVcache aware routing is enabled for users?
I'm going to say that this is for people who are really the experts on this topic around cache-aware routing. I am not an expert in this topic, so I wouldn't be able to answer that question. I wouldn't be able to answer that question with real conviction. So I think I'm going to pass on that if I'm allowed.
Yeah, is there anybody else on the call that has any insight to that question?
Okay, so I think that's another question we'll try and come back to the user when we talk to people that are more experts on the topic. And actually, while we're on that, I would ask, anyone that's looking at this or maybe is on the call to, from the different, inferencing platforms, like your LMDs, NVIDIA, Dynamo, K-Serve, etc., to reach out and say, right, what are you looking for? What's your requirements? What events are you looking for? Because I think we've only done the bare tip of the iceberg here, and I think it's the requirements that come down from above will drive what events we generate. Any other?
Another one in the chat. I've been testing LMCache across versions 0.10 to 0.13, and I can clearly see overall performance improvements. However, I noticed a behavioral difference in KV offloading. In 0.10, when I send a small prompt, less than 20 tokens, KV blocks are offloaded to NVMe. In 0.13, KV blocks are not offloaded for the same prompt. Offloading only seems to happen when the input tokens are combined with the output tokens, and it approaches the max model len. Was there any intentional change in the offloading store logic between those two versions?
So what versions?
0.3.10 and 0.3.13.
Sammy, you might be on the call. Would that have to do with the cache, the chunking, the default chunking layer changing?
Yeah, that's exactly the change that happened, is that chunks that aren't full chunk size, such as 20, if your chunk size is 256, are not stored by default anymore.
Okay. Yeah, that caught me out as well during the testing when I came back from the holidays. with one of the PRs that I hadn't gotten in, so yeah. If that person has questions further on that, ask him to just reach out in the Slack channel, inside and probably general or one of those, or questions.
Yeah, questions is good because the bot will pull stuff from the docs to help with answering if a living human doesn't get there in time.
And we can go a bit deeper on it as well with the answers and give the links to docs and stuff.
I guess that's it. Thank you very much, Marty.
You're welcome. I'll just stop sharing there a second. So there we go.
Great. So that's all we have for today. Our next office hours is March 12th. That's the second Thursday of the month. We'll be doing that every month. And stay tuned in the office hour channel and Slack for updates about that call. And thank you so much for joining us, everyone. And we'll see you in Slack.
Thank you, folks.
Thank you.